Hey Code Mechanics, welcome back. Today, we're diving deep into a tricky, yet crucial, diagnostic code, P061B. If you work on modern vehicles, especially those with complex powertrain control modules, or PCMs, you've probably bumped into this one. It's often misunderstood, or worse, misdiagnosed. P061B is titled Internal Control Module Torque Calculation Performance. Now, that sounds heavy. But stick with me, we're going to break down exactly what that means, why it sets, and the most reliable ways to diagnose and fix it. First, let's establish context. In modern engines, especially those equipped with electronic throttle bodies, sophisticated torque modeling is absolutely essential. The engine control unit isn't just measuring airflow anymore. It's calculating the precise torque output based on driver demand, required transmission shift points, emissions controls, and a whole host of other inputs. Think of the PCM as a hyper-efficient air traffic controller for power. This torque model is what allows the engine to deliver smooth, precise power under all operating conditions. When the PCM sets a P061B, it's essentially saying, my internal math is failing. Specifically, the internal self-check routines within the PCM have identified a discrepancy between the calculated torque value and one or more of the monitored inputs or outputs. It means the critical calculation that determines how much power the engine asterisk should be making does unmatch up with what the engine is asterisk actually doing, or what the PCM thinks the engine is doing based on redundant checks. What are these crucial inputs? We're talking about throttle position sensor data, accelerator pedal position sensor data, mass airflow sensor readings, oxygen sensor readings, and even transmission input speed data. The PCM uses these dozens of inputs to build its theoretical torque model. If even one of these sensors provides skewed or intermittent data, the resulting torque calculation goes sideways, and the PCM flags the P061B code as a serious internal calculation error. Now, here's where most people go wrong. Because P061B is labeled as an internal control module code, the immediate reaction is often, the PCM is bad. Replace the computer. And look, sometimes, yes, the internal circuitry or programming of the PCM has failed, requiring replacement, but the overwhelming majority of P061B codes are set, not because the computer itself broke, but because an input signal is telling the computer bad information, causing its calculations to fail this up. Replacing the PCM without addressing the root cause is an expensive guess. And trust-me, the new PCM will set the exact same code, usually within minutes of operation. So, how do we properly diagnose this performance calculation error? We need a methodical approach, starting with the basics and moving to advanced diagnostics. Step 1 is always checking power and grounds to the PCM. A sudden voltage drop or intermittent ground issue can absolutely corrupt the complex. High-speed calculations happening inside the module. Always perform a thorough wiggle test and look for signs of corrosion or harness damage, especially near the firewall or battery tray. Step 2 involves meticulous data logging. You need a professional grade scan tool capable of reading enhanced parameters, not just generic OBD to data. We need to focus specifically on the primary inputs to the torque calculation: throttle position, accelerator, pedal position, and mass airflow. Watch these parameters live. Are they smooth? Do they show sudden, illogical jumps or dropouts? Pay close attention during acceleration and deceleration. If the throttle position jumps from 15% to 50% momentarily without a corresponding change in the pedal position, you found your culprit a bad sensor or wiring issue that's throwing off the torque math. Step 3 is crucial for specific applications. Check for software updates or technical service bulletins, TSBs. Many P061B issues are actually known software glitches or calibration mismatches, especially in newer platforms. A simple reflash can often resolve a phantom calculation error that was tripping the code, saving you hours of frustrating electrical testing. Finally, if all inputs are clean, power and grounds are perfect, and the vehicle has the latest software, then, and only then, do we consider the possibility of internal PCM failure. But remember the hierarchy. Inputs first, power second, software third, and the computer itself last. This logical flow prevents premature, expensive, and incorrect PCM replacement. P061B might seem intimidating, but it is just a PCM, alerting you that its internal safeguards have been triggered by inconsistent data. Approach it methodically, prioritized verifying sensor accuracy and wiring integrity, and you'll solve the issue without resorting to unnecessary control module replacement. If this breakdown helped you simplify this complex code, hit that like button. Let me know in the comments what complex diagnostic code you want me to tackle next. Thanks for watching. Subscribe for more CodeMechanic deep dives, and I'll catch you on the next repair.